Example number 3. Describe the effect on y of doubling x if letter A, y varies directly with x. Letter B, y varies inversely with the square of x. Letter C, y varies directly with the cube of x. Okay, so let us solve this using our perception. So suppose that we have y and x, and there is a variation. A variation meaning we have a certain constant k with the which is intervening between y and x. Okay, so letter A says that if your y varies directly with x, then what if we double x? What will happen to our y? So this is kx, okay? And our k is the constant of proportionality, or the variation constant, okay? Okay, so k is our constant of proportionality. So if we double our x, so y now becomes k times 2x, right? So what will happen to our y? Our y becomes 2k times x. Am I correct? So look that our y prime, so if we set this out as y prime, then that's equal to the original. We have our original is kx, okay? And that will give us 2 times our y. Am I correct? Because kx is our y. So meaning the effect on doubling x will be twice. So we get twice the value of the y. That is for the first question. So look that y is also doubled. So y is also doubled, and that means that we multiply it by 2. Okay? Letter B. Y varies inversely with the square of x, meaning we have a certain y is equal to k over x squared. So if we double our x here, then we will have y prime. Let's say that is our y prime. That would be y is equal to k over 2x squared, giving us k over 4x squared, giving us the original. Our original is k over x squared, so we have 1/4 of the original, which is y. So it is multiplied by 1/4. Okay, letter C. Y varies directly with the cube of x. So we have y is equal to k x cubed. And what happens if we double our x? Then we will have y prime is equal to k times 2x cubed. This will give you k times 8x cubed. Therefore, doubling the x in this case will give us, what is our original? Kx cubed, right? So our kx cubed is here. So it is actually multiplied by 8. So you get 8 times y, the original y, okay? So the new y is multiplied by 2 raised to 3, or 8. So in this case, we have it's multiplied by 2 raised to negative 2, and this one it's multiplied by 2 raised to 3. Okay, this one is multiplied by 2 raised to 1. So that's the effect of doubling our x for a given variation. Okay. Example number 4. Suppose that f is a direct square power function, and that f of 5 is equal to 1000. Find f of 20. So maybe we would need a table. So let's have a table. Okay, and this is our separation line for the x and f of x. Okay, so if our x is 5, so let's say this is 5, what is our f of x? So this is our f of x. This is f of x. Okay, and if our x is equal to 5, then our f of x is equal to 1000. And if our x is equal to 20, then what is our f of 20? Notice that this is a direct square power function. So this is a power function. And for power function, they have a property which is about multiply property or pattern. So let us say our 20 is actually let's rewrite our 20 as, what's wrong with my pen? Okay, let's write 20 is equal to 4 times 5. Then our f of 20 is therefore f times, or f of 4 times 5. Am I correct? Now this is a direct square variation, meaning that if you multiply the x by a certain constant, then the resulting f of x will be multiplied also by the square of that constant. So what do we mean by that? For example, we multiply our x by 4. We multiply our x by 4. Okay? What is happening here? Okay. If we multiply our x by 4, then our f of x will definitely be multiplied by, because this is a direct variation, so this will give us an f of x which is multiplied by 4 square. Am I correct? So that would give you a value which is f of 5 times 4 square. This is 5. Okay, because we multiply our x with 4, and then we will get a result which is multiplied by 4 square. That's a direct square variation. So our f of 20 then, in this case, our f of 20 would then be equal to f of 4 times 5, of course, and this will give us 4 squared times f of 5. And what is our f of 5? By the way, our f of 5 is 1000. So we have 4 squared times 1000. Just erase the dot. So this will give us 16 times 1000. So we have 16,000. Therefore, our f of 20 is 16,000. Because it is a direct square power function.